Good evening to one and all. Welcome to our favorite video channel Sri Ganit Vijnana Sarvasvam. This is B. Ramesh Kumar, JL in Mathematics, your maths teacher. We discuss linear system of equations direct methods. Now today we discuss Gauss elimination method. To solve the given system using Gauss elimination method. First of all, we discuss the working procedure of this method. Let us consider one system of equations. Let it be a1x plus b1y plus c1z equals to d1, a2x plus b2y plus c2z equals to d2, a3x plus b3y plus c3z equals to d3. So this is one of the system, and first of all we write the system in matrix form, which implies we take the coefficients of x, y, z, a1, b1, c1, a2, b2, c2, a3, b3, c3. This is the coefficient matrix, and the variable matrix is column matrix x, y, z. Similarly, the constant matrix is also column matrix d1, d2, d3. So this is the matrix form. Here we take this is A, this is X, this is equals to some D. So which implies the matrix form is Ax equals to D. Now first we write the augmented matrix of the system. Therefore the augmented matrix is, in this augmented matrix first we write the coefficient matrix, that is a1, b1, c1, a2, b2, c2, a3, b3, c3. And besides this coefficient matrix we write constant matrix, that is d1, d2, d3. So this is augmented matrix. So here using Gauss elimination method. So in this Gauss elimination method, the augmented matrix can be converted to upper triangular matrix. So here the augmented matrix can be converted to upper triangular matrix. Here the definition of upper triangular matrix means, suppose A is any square matrix. In this square matrix, this is the principal diagonal. Below the principal diagonal, all elements are zeros. Then that matrix is called upper triangular matrix. So this type of matrix is called upper triangular matrix. In principal diagonal, every element equals to 0. So the augmented matrix also converted to upper triangular matrix using elementary row transformations. Here using elementary row transformations. Elementary row transformations. Using elementary row transformations, here the matrix can be converted to upper triangular matrix. This is the main step. So here also this type of formation. Now we do not use any transformation. The remaining elements can be zeros. Cannot be zeros. So here that matrix already converted to upper triangular. Here the name of upper triangular matrix is in echelon form. Already we discussed it. So this type of upper triangular matrix which is in the form of echelon form. Now the form is echelon form. So here we observe the augmented matrix can be converted to upper triangular matrix. Already this is the form of echelon. So this is called echelon form. Here using only elementary row transformations. Now in this the augmented matrix can be converted to, suppose here A1 using transformations, A1 will be reduced to some A1 dash, here B1 dash, C1 dash, and also this is D1 dash. Similarly here the principal diagonal elements 0, B2 dash, C2 dash, D2 dash, 0, 0, C3 dash, some D3 dash. So using transformations, this augmented matrix can be converted to upper triangular matrix. Now that upper triangular matrix can be considered as A1 dash, B1 dash, C1 dash, D1 dash after using row transformations. Similarly 0, B2 dash, C2 dash, D2 dash, 0, 0, C3 dash, D3 dash. So this is the upper triangular matrix. So here using backward substitution, here first of all we write the equations using this augmented matrix. The first equation is some A1 dash x plus B1 dash y plus C1 dash z equals to some D1 dash. Similarly we write here the coefficients of x equals to 0. Now the coefficient of y is B2 dash and coefficient of z is C2 dash. Now here B2 dash y plus C2 dash z equals to D2 dash. Similarly we write here coefficient of x and coefficient of y are zeros. So the coefficient of z is C3 dash. So C3 dash z equals to some D3 dash. Now in these equations we go to backward substitution. Backward substitution means first we find the value of z, then that value substitute in the second equation. Now we get the value of y. Now here we substitute the values of y and z, substitute in first equation, then we get the value of x. So this process is called backward substitution. Now using backward substitution, we get the values of z, y and x. So this is the solution of the given system. Here x equals to the variable matrix x, y, z, that equals to some values. Now for example, here we take some alpha, beta, gamma. This is the solution. This is the solution. So this is working procedure of Gauss elimination method. Now first of all we write the matrix form and we take augmented matrix and it will be converted to upper triangular matrix using elementary row transformation only using elementary row transformations. Now this upper triangular matrix which is of the form is echelon form. Echelon form means here zeros, in between zeros are increased by second row to third row to fourth row. Here we take the matrix, quotient matrix is 3 by 3. So any order. Now here we take four variables, 4 equations, 5 variables, 5 equations, more than 3. Already using this method to solve the any system which consists the variables 3, 4, 5, 6 up to and so on. Similarly here the equations also 3, 4, 5, 6 up to and so on. Number of variables is equals to number of equations. So this is the procedure of Gauss elimination method. Now we go to the problems. Now the first problem is solve the system using Gauss elimination method. The first equation is x plus y plus z equals to 6. Second one is 3x plus 3y plus 4z equals to 20. Third one is 2x plus y plus 3z equals to 30. Now here using this method to solve this system. Now first we write the augmented matrix of the given system. The augmented matrix. Now here we write in this augmented matrix, first we take quotient matrix, that is some A, and besides quotient matrix we write constant matrix, that is some D. Here the quotient matrix is 1, 1, 1, 3, 3, 4, 2, 1, 3. The constant matrix is 6, 20, 13. So this type of matrix is called augmented matrix. Now here using row transformations, this augmented matrix will be converted to upper triangular matrix. Now here using row transformations, here we observe that the first row first element is 1. Now using this one, the remaining first elements of second row and third row elements are zeros. So here this is 1. Now multiply with 3 and subtract from second row, this is 0. Multiply with 2 to first row and subtract from third row, this will be 0. So here we take two row transformations. R2 changes R2 minus 3R1. Similarly R3 changes R3 minus 2R1. Now using the first one, first row does not change, 1, 1, 1, 6. In second row, 3 minus 3, 0. 3 minus 3, 0. 4 minus 3, 1. 20 minus 18. 3 into 6, 18. 20 minus 18 means 2. Here 2 minus 2, 0. 1 minus 1, 1 minus 2. Sorry, 1 minus 2, minus 1. 3 minus 2, 1. 13 minus 12. This is also 1. Now here we interchange second row and third row. R2 interchanged by R3, that equal to the reduced matrix is first row does not change, second row third row are interchanges. 0 minus 1 1 1 0 0 1 2. So here we observe that this is the principal diagonal elements. So below the principal diagonal all elements are zeros. Now this type of matrix is called upper triangular matrix. So this is upper triangular matrix. So here we write equations. Now the first equation is x plus y plus z equals to 6. Here the second equation is minus y plus z equals to 1. Similarly the third one is z equals to 2. Now solve these equations to find x, y, z. Here using backward substitution method. By using backward substitution, we get, here we take z equals to 2. This will be substitute in equation 2. Put z equals to in equation 2. We have minus y plus 2 equals to 1, which implies minus y equals to 1 minus 2, that equals to minus 1, which implies y equals to 1. Here both sides minus will be cancelled. Similarly, put z equals to 2, y equals to 1 in equation 1. We have here x plus y means 1 plus z means 2, that equals to 6, which implies x equals to 6. 1 plus 2, 3. It will be taken to right side, that is minus 3. So this is 3. So therefore the solution of the given system is x equals to 3, y equals to 1, z equals to 2. So this is the solution for the given system. Now the second problem is x plus 2y plus z minus w equals to minus 2. 2x plus 3y minus z plus 2w equals to 7. X plus y plus 3z minus 2w equals to minus 6. And x plus y plus z plus w equals to 2. Now using Gauss elimination method, solve this system. So the another name of Gauss elimination method is Gaussian elimination method. Here we also denoted Gaussian elimination method. Now we go to the solution. First we write the augmented matrix. Here the augmented matrix is here generally we take the coefficient matrix is denoted by A and the constant matrix is denoted by D. So D right beside the coefficient matrix. Here augmented matrix AD equals to, here we take the coefficients of x, y, z. In first equation 1, 2, 1 minus 1 and the constant is minus 2. Similarly in second equation 2, 3 minus 1, 2, 7. 1, 1, 3 minus 2 minus 6. This is the third equation. So here the fourth equation coefficients are 1, 1, 1, 1, 2. Now this is augmented matrix. Here this augmented matrix will convert to upper triangular matrix. Now using elementary transformations. Here we observe that the first element of first row is 1. Using this one, the remaining first elements of second, third and fourth rows are equals to zeros. So here multiply with 1 and subtract from second row, this is 0. And subtract from third row to first row, this is also 0. Similarly, same process will be followed by fourth row also. So here we take the transformations. R2 changes R2 minus to R1. R3 changes R3 minus R1. And R4 changes R4 minus R1. Now using the first one, the first row does not change. 1, 2, 1, minus 1, minus 2. In second row, R2 minus 2 R1. 2 minus 2 into 1, 0. So 3 minus 2 into 2, 3 minus 4, minus 1. Here, minus 1 minus 2 into 1, minus 3. Here, 2 minus 2 into minus 1 plus 2, 4. And here also, 7 plus 2 into 2, minus 2 into minus 2, 7 plus 4, 11. Similarly, using third row operation, 1 minus 1, 0, 1 minus 2, minus 1, 3 minus 1, 2, minus 2 plus 1, minus 2 plus 1, minus 1, minus 6, plus 2, minus 4. Similarly, fourth row operation, R4 minus R1. Here, 1 minus 1, 0, 1 minus 2, minus 1, 1 minus 1, 0, 1 plus 1, 2, 2 plus 2, 4. So, this is reduced matrix. Here, we observe that the second row, second element is minus 1. Using this minus 1, subtract from third row to second row and subtract from fourth row to second row. These are also zeros. Now the transformations are R3 changes R3 minus R2 and R4 changes R4 minus R2. Now using the third row operation, here first two rows does not change. 1, 2, 1 minus 1, minus 2. 0, minus 1, minus 3, 4, 11. In third row, 0 minus 0, 0, minus 1 plus 1, 0, 2 plus 3, 5, minus 1 minus 4, minus 5, and minus 4 minus 11, minus 15. Using fourth row operation, R4 changes R4 minus R2, 0 minus 0, 0, minus 1 plus 1, 0, 0, minus of minus 3 plus 3, and 2, 2 minus 4, minus 2, and 4 minus 11, minus 7. Now here, divide with 5, the third row will be converted to 1 minus 1, minus 3. So R3 changes R3 divided by minus plus 5. So here the resultant matrix, first two rows does not change. The third row is divided by 5. 0, 0, 1, minus 1, minus 3. So 5 by 5, 1, minus 5 by 5, minus 1, minus 15 by 5, minus 3. In fourth row also does not change. 0, 0, 3, minus 2, minus 7. Now here, using third row, third element. Third row, third element is 1. Using 1, in fourth row, third element converted to 0. Multiply with 3 to third row and subtract from fourth row. This is also 0. Now R4 changes. R4 minus 3R3. So the resultant matrix is first three rows does not change. 1, 2, 1, minus 1, minus 2. 0, minus 1, minus 3, 4, 11. 0, 0, 1, minus 1, minus 3. This is 0, 0, 3 minus 3, 0, minus 2 plus 3, 1, minus 7 plus 9, 2. So, this is the resultant matrix. Here we observe that in the coefficient matrix, this is principal diagonal. The below the principal diagonal, all elements are zeros. So here we observe this is upper triangular matrix. So which is upper triangular matrix. Now by using backward substitution, method, here the equations are x plus 2y plus z minus w equals to minus 2, which is equation 1. The second equation is minus y minus 3z plus 4w equals to 11. This is equation 2. Similarly, we write third equation z minus w equals to minus 3. This is the third equation. In fourth one, w equals to 2. This is fourth one. Now these are four equations using backward substitution. Now put w equals to 2 in equation 3, we get z, and substitute z and w in equation 2, we get y. Similarly, substitute y, w, z. Substitute in equation 1, then we get value of x. First put w equals 2 in equation 3. We have here z equals to minus 3 minus w, take it to right side, that is plus w. So minus 3 plus 2 equals to minus 1. So this is z value. Similarly, substitute z equals to minus 1, w equals 2 in equation 2. Here we get minus y equals to 11 plus 3z minus 4w. Here 11 minus 3 into z, 3 into minus 1, plus 3 into minus 1, minus 3, minus 4 into 2, minus 8. So 11 minus 11, this is 0. Similarly, substitute y equal to 0, z equals to minus 1, w equals to 2. Substitute y equals to 0, z equals to minus 1, and w equals to 2 in equation 1. Therefore, x equals to minus 2 minus 2y minus z plus w. So minus 2 into y value 0 minus z. Z value minus 1 minus z is plus 1. W is 2. So plus 2. Here minus 2 plus 2 cancel. Therefore x equals to 1. So this is the value of x. Therefore the solution of the given system is x equals to 1, y equals to 0, z equals to minus 1 and w equals to 2. So this is the solution for the given problem. Now using same procedure for more problems, to practice for more problems, to understand this method. So this is the procedure and solution of Gauss elimination method. Okay, thank you.